Assalamu alaikum wa rahmatullahi wa barakatuh. Math grade 6. Today we want to learn volume of rectangular prism. We are in chapter 10 in geometry lesson 1. Lesson 1, volume of rectangular prism. Volume of rectangular prism. Now see with me this video.
Welcome to today's podcast on volume. In today's session, we are going to learn how to use a formula to calculate the volume of any rectangular or square prism. Firstly, what is volume? Pause this podcast and discuss this with the person next to you. Volume is the amount of space an object takes up. So, how many 1 centimetre cubes will fit in the object? In class, you may have been using the 1 centimetre cubes to work out the volume of rectangular prisms. Today, we are going to learn how to use a formula to work out the volume of any rectangular prism. Before we start, it's very important that we know what unit of measurement we use to measure volume. When measuring volume, we use cubic centimetres or cubic metres. So, how do we
السلام عليكم
calculate
مستر
volume?
محمد هوني. خلاص.
To calculate volume, we need to use a formula. The formula for calculating the volume of a prism is length times width times height. We can also write it V equals L times W times H. So let's have a go at the formula. This rectangular prism has a length of 5 centimetres, a width of 2 centimetres and a height of 3 centimetres. Now, remember our formula? Volume equals length times width times height. So our prism has a length of 5 centimetres, a width of 2 centimetres and a height of 3 centimetres. So to work out our volume, we need to times 5 times 2 times 3. Let's have a go. The first thing we need to do is times the length, 5 centimetres, by the width, 2 centimetres. So we need to times 5 times 2. So 5 times 2 equals 10. So 10 is the length times the width. Our next step is to times 10 centimetres, which is our length, times our width, by 3 centimetres, which is our height. So 10 times 3 equals 30. So the volume of our prism is 30 centimetres cubed, because we times 5 centimetres our length, times 2 centimetres our width, times 3 centimetres our height, which gave us 30 centimetres cubed. Now that you know the formula, let's have a go at doing the next problem. A truck has a trailer that has a length of 7 metres, a width of 2 metres and a height of 4 metres. What is the volume of the trailer? Make sure you remember the formula. Volume equals length times width times height. So the volume of our trailer is 7 times 2 times 4. Pause the podcast here. You may wish to do this problem individually, in pairs or as a class. How did you go? The volume of the trailer is 56 metres cubed. We are now at the end of our podcast. Thank you for watching and I hope you have enjoyed learning about volume today. Now you know how to use the formula length times width times height to calculate the volume of a rectangular prism or a cube. You can download this podcast from your school's network.
So this is the meaning of the volume and what is the formula to solve the volume. And today we want to learn how to find the volume of rectangular prisms. How to find the volume of rectangular prisms. As you see here, this figure, rectangular prism. Rectangular prism. Now see with me this video.
Switch. TP.
Volume is measured by how many cubic units it would take to fill a given space. The cubes in the green is a cubic unit. The amount of cubic units it takes to fill a defined space is what we call volume. The shown geometric solid is a rectangular prism. To find the volume of any rectangular prism, we simply multiply the length times the width times the height. The length and the width of the rectangular prism are always at the bottom of the shape. These two dimensions make up the base of the rectangular prism. In this case, the length is 4 and the width is 3. Multiplying the length times the width will give you the area of the prism's base. This is a two-dimensional measurement. After multiplying the length times the width and getting the area of the rectangular prism's base, by multiplying it by the rectangular prism's height, that will give us the volume. Multiplying the area of the prism's base by the height is filling up the prism or adding depth. This is what gives our rectangular prism a third dimension, or gives it volume. We can clearly see when multiplying the length times the width of the rectangular prism, we come up with 12 square units, which would be the area of the rectangular prism's base. Remember, this is only a two-dimensional measurement. To give it depth or volume, we must now multiply the area of the rectangular prism's base of 12 by whatever the height is to fill up the rectangular prism or to add depth or volume. If we multiply the area of the base, which is 12, by a height of 1, that would give us 12 cubic units, which would be how many cubes it would take to make one level of our rectangular prism. Adding 2 levels of 12, we would get a total of 24 cubic units. 3 levels of 12 would give us 36. 4 levels of 12 give us 48 cubic units. And of course, 5 levels of 12 would give us 60 cubic units. We could say that each level of the rectangular prism contains 12 cubes. There are 5 levels of 12 cubes for a total of 60.
Okay. Now vocabulary. We have new words. We want to learn these words. The first one, what's the meaning of a three-dimensional figure? Means has length and width and height. Three-dimensional figure means has length and width and height. Three sides, length, width and height. As you see here, this is a three-dimensional figure. As you see here, this is the length and this is the height. This is the height and here the width. Here the width. What's the meaning of a prism? Is a three-dimensional figure with two parallel bases that are congruent polygons. As you see here, this figure, this is a prism. This prism has two faces. The first face here up, the base up, and the base down. The two bases here parallel and congruent. So this is the meaning of a prism. In a rectangular prism, the bases are congruent rectangles. The bases are congruent rectangles. So as you see here, here we have a rectangular prism. A rectangular prism. Here we have rectangle, and down we have rectangle. So the two opposite bases are equal or congruent and parallel, and the kind are rectangles. The kind are rectangles. What's the meaning of the volume? What's the meaning of the volume? The volume is amount of space inside a three-dimensional figure. And cubic units, the volume measured in cubic units, U exponent 3 or U cubic. See now with me this video.
We get it. You don't really want your kids watching videos, but it can have certain advantages.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. All right, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units? And there's another similarity too. Do you remember how you can use square units to measure the area of any 2D shape, not just squares? Well, you can use cubic units to measure the volume of any 3D shape, not just cubes. To see how that works, take a look at this 2D circle and this 3D object called a sphere, which is like a ball. Just like you can use a bunch of small squares to approximate the area of the circle, you can use a bunch of small cubes to approximate the volume of the sphere. And here's the really cool part. The smaller the squares you use, the closer their combined area will match the area of the circle. And the smaller the cubes you use, the closer their combined volume will match the volume of the sphere. Okay, so volume is a 3D quantity for measuring 3D objects. But since we've also talked a lot about area in this video, I want to point out that 3D objects also have a type of area that you don't want to confuse with volume. You might remember from our previous videos that 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in a similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is a lot like it sounds. It's the area of the object's outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box. All right, so now that you understand what volume is, and you won't confuse it with surface area, we're going to spend the rest of the video learning how to calculate the volumes of some basic geometric shapes. But before we do that, I want to quickly mention something important about terminology, or the words we use to describe things in math. Most of the time, people agree on what to call things in math, but not always. And that's especially true when it comes to the words that we use to describe the dimensions of geometric objects. Take the words length, width, and height, for example. If I have a rectangle, I can name its two dimensions, length and width, like we did in the area video. But I could also name them width and height if I wanted to. The actual names of the dimensions really aren't important, so different teachers might use different names. The important thing is to be flexible and realize that the math concepts are the same, even if different words are used to explain them. For example, the area of a rectangle is always found by multiplying its two side dimensions together, no matter what they're called. Okay, back to calculating volumes. A lot of 3D shapes can be formed by taking a 2D shape and then extending it along the third dimension. For example, if you start with a rectangle and then extend it along the third dimension, you get a 3D shape called a rectangular prism. If you start with a triangle and then extend it along the third dimension, you get a 3D shape called a triangular prism. And if you start with a circle and extend it along the third dimension, you get a 3D shape called a cylinder. From the others, you might have thought that it should be called a circular prism. But technically, prisms are shapes that are formed by extending a polygon. And since a circle is not a polygon, the resulting shape is not called a prism. Okay, so the good news is that there's a general formula for calculating the volume of these types of 3D shapes. All you have to do is find the area of the original 2D shape that got extended and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle, and its dimensions are 4 centimeters by 3 centimeters. So to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40, so the area of the triangle is 40 inches squared. Now all we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches, and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters. So if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle was extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of this cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape and then you multiply it by the length that it was extended, and that gives you the volume. And it works for any 2D shape. It works for trapezoids or pentagons or diamonds or stars or hearts. All right, man. Now that I know how to accurately calculate volumes, playtime is way more fun. Of course, not all 3D shapes are made by extending a 2D shape along a third dimension. Some are made by rotating a shape around an axis, like the sphere we saw earlier in the video, for instance. One way to form a sphere is to rotate a 2D circle around one of its diameter lines. And another common 3D shape that can be formed by rotating a 2D shape around an axis is a cone. A cone can be formed by rotating a right triangle around one of its two perpendicular edges. Since the formulas for finding the volumes of spheres and cones are more complicated to explain, we don't have time to learn how we arrive at them in this video. So for now, it's best if you just memorize the formulas so you can use them on tests if you need to. To find the volume of a sphere, you use the formula volume equals 4/3 times pi times radius cubed. And to find the volume of a cone, you use the formula volume equals 1/3 times height times pi times radius squared. Let's try one example of each before we wrap up. Here's a sphere with a radius of 2 centimeters. Fortunately, that's the only dimension we need to find its volume. Our formula says that the volume of a sphere is equal to 4/3 times pi times radius cubed. Cubing the radius means multiplying it by itself 3 times. So we take 2 centimeters times 2 centimeters times 2 centimeters, which equals 8 centimeters cubed. Next, we'll multiply that by our approximation for pi. 3.14 times 8 is 25.12. And last, we multiply that by 4/3, which is the same as multiplying by 4, then dividing by 3, which gives us a volume of 33.49 centimeters cubed. Now let's try a cone. To use our formula to find the volume of a cone, we need to know 2 things: the radius of the circle that forms the base of the cone, and the height of the cone, which is similar to the height of a triangle. It's the distance from the point at the tip of the cone straight down to the center of the circular base. The radius of the base of this cone is 3 feet, and its height is 9 feet. So first, let's plug that radius into our equation and square it. 3 feet times 3 feet is 9 feet squared. Next, we multiply that by pi, again using 3.14, and we get 28.26 feet squared. You may notice that that's just the area of the base circle. But now we need to multiply that base area by 1/3 times the height of the cone. 1/3 times 9 feet is 3 feet. And 3 feet times 28.26 square feet gives us 84.78 cubic feet, which is the volume of the cone. All right, so now you know a lot about volume. You know that it's a 3-dimensional quantity of geometric objects, and you know that we measure volume with cubic units. You also learned how to calculate the volume of some basic 3D shapes. Of course, there's a lot of other 3D shapes that we didn't have time to cover in this video, but now you know about some of the most common ones. The key is to put what you've learned into practice by trying some exercise problems on your own. As always,
Okay, this is the meaning of the volume for many prisms. And what is the formula to solve the volume for rectangles or rectangular prism? So the volume, the symbol of volume will be V of rectangular prism is the product of its length L times width W and height H. So the formula I can write V equal L times W times H. This is L, the length, and this is W, the width, and this is the height H. L times W, the area of the rectangle, So I can write L times W equal P. P means the area of the rectangle, So I can use L times W times H or I can use P times H, P times H. And what's the meaning of P? P equal L times W. Is it then? So I can use this formula or this formula. I can use this formula or this formula, the same idea, the same idea. For example, find the volume of prism. I have here a prism, and as you see here, the base rectangle means I have rectangular prism, As you see here, we have the length 10 and the height 3 and the width 4. So how to solve, how to find the volume? At the first step, write the formula. V equal L times W times H. The value of L, 10. The value of the width will be 4. And the value of H will be 3. So V equal 10 multiplied by 4 multiplied by 3. 10 multiplied by 4 will be 40. 10 multiplied by 4 will be 40. 40 multiplied by 3 will be 120. And the unit here, meter times meter times meter, will be meter exponent 3. I read it, meter cubed. So this is the unit to measure the volume. Example 2. Find the volume of prism. Look to this figure. As you see here, the base rectangle means I have a rectangular prism. The dimensional here, I have here the height. This is the height. And this is the length. And here width. So H equal 12, L equal 6, and W equal 5. So how to find the volume? Write the formula. V equal L times W times H. So the value of L will be 6. So write here 6 multiplied by the value of W will be 5, and the value of the height will be 12. So I can write now 6 times 5 times 12. 6 times 5 will be 30. 30 times 12 will be 360. Now inch times inch, inch exponent 3. So I can read it inch cubed. So this is the unit to measure the volume. As you remember, we measured the area by squared, and now we measure the volume using cubed. Here we have some videos. When you have free times, you can see all these videos. And this is our lesson today. And tomorrow, inshallah, we will continue this lesson. Now, who has a question now?
Mister, today we have homework.
Inshallah. Who has a question now? Throw our lesson. Yes.
Mister, the exam will be from the revision sheet. Will be same of the revision.
The revision sheet example. The revision sheet example for the exam, but not include the exam. Not the same exam.
مستر أنا حافظ كل شيء ودارسنا وكل شيء.
You want to study from the book.
Mister, easy.
Cannot write
from
the exam.
أستاذ أنا بروح بصلي.
مستر بس شو اسمه علي حمد قال لي إن
أستاذ أنا بطلع بروح بصلي
يدخل على تيمز عشان كذا ما حضر الحصة.
Okay, who has a question now? Throw our lesson inside our lesson.
No, Mister, no questions.
Right, what is our lesson today?
Rectangular prism.
Mr. Finding the area of
volume of
3D shapes.
The area or the volume?
rectangular prism.
Volume of rectangular prism. Volume of rectangular prism.
Prisms.
So our lesson today, volume of rectangular prism. So today we want what's the meaning of the volume and what is the unit to measure the volume and how to solve the volume for rectangular prism. Now, what is the formula to solve the rectangular prism? What is the formula to solve the
L
rectangular
times W times H. Mr. V equal L times W times H.
Okay, V equal L times W times H. What's the meaning of L?
Length.
And W?
Width.
And H?
Height.
And what is the unit to measure the volume?
V. Cubic 3.
Excellent, excellent. طيب. No question, it's clear for all?
Yes.
Yeah. Thank you.
طيب. Let us to take attendance now. Tomorrow we'll continue the same lesson, inshallah.
إن شاء الله. مستر محمد أنا في الفيجن ما فهمت اللي اتش. مستر
Yes.
مستر في الفيجن ما فهمت آخر سؤال 18 اللي فيه 12 over h is بعدين bigger ولا smaller 5.
12 over H.
هاي مستر آخر واحد السؤال 18.
Okay, طيب wait to the last of this period. أحمد سالم.
Okay.
أحمد سالم. أحمد.
موجود.
Mr. he's absent.
Okay, حمد الظاهري.
موجود.
حمد.
absent.
حمد الظاهري. Okay. حمد الجابري.
مستر حمد الجابري موجود.
حمدان العامري.
مستر بطلع. اوكي يلا مع السلامة.
موجود أستاذ. موجود أنا.
حمدان علي.
موجود.
زايد النعيمي. زايد النعيمي. زايد. زايد النعيمي. غايب. اوكي. سالم هداف.
موجود.
موجود. سالم هداف. سالم هداف.
غايب.
اوكي. عبد الرحمن.
موجود.
اوكي. عبد الله التميمي. عبد الله التميمي. عبد الله. طيب.
غايب.
عبد الله الأحبابي.
موجود مستر موجود.
اوكي. علي حمد.
غادر مستر.
ايه علي حمد الرميثي.
موجود مستر موجود. هو دخل علينا يقول.
اوكي. عيسى. عيسى.
موجود.
فلاح.
موجود أستاذ موجود.
منصور الظاهري. منصور أحمد. منصور أحمد. منصور أحمد الظاهري. منصور راشد البيك.
موجود.
منصور نايف.
موجود مستر موجود.
بلاد.
موجود.
هزاع.
موجود هزاع.
يلا استاذ مع السلامة.
مع السلامة. خلفان.
موجود.
اوكي. خليفة.
موجود استاذ.
ويس.
موجود.
دياب. سالم. سالم الجمعة.
موجود استاذ.
سلطان خليفة الظاهري. سلطان. سيف. سيف سالم. سيف سالم. عبد الله الجابري.
موجود استاذ.
فارس. 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 طيب محمد الراشدي.
راح يصلي.
محمد
موجود
عبد
استاذ
العزيز.
محمد سالم موجود. استاذ
طيب،
محمد الراشدي موجود.
محمد عبد العزيز. محمد عبد العزيز. محمد عبد العزيز.
طيب.
محمد عمار.
موجود.
محمد عمر.
موجود.
منصور علي. منصور علي.
موجود استاذ. موجود.
منصور محمد.
موجود.
منصور. اوكي. موسى.
موجود استاذ.
ناصر.
موجود استاذ موجود.
اوكي. منصور نايف. وير از منصور نايف؟
Yes mister.
Tell me your question.
Wait mister. Mister, it's 17. The solution of the inequality d over 12. Then the wait, mister.
D over 12. Yes.
Mister, this one. Here.
D over 12 greater than or less than or
Greater than, I think.
Greater than.
The
Like this.
other one. Less than.
Less than. Like this.
Five.
Less
Then
than.
5.
Less than 5, huh?
Yes. And
Okay.
the answer equal 60.
D equals 60.
Yes. It says here in the equation.
D equals 60 like this.
No, Mister, the answer is D, smaller than 60.
Yes. Here we have not equation, inequality. Here we have inequality. For easy way, you have many methods to solve this idea, but for easy way, directly when you see here fraction, multiply the numbers. Multiply the numbers. So you can write here D, and the same signal here, less than, and now here 12 times 5. 12 times 5. So you can write D less than, now 12 times 5 will be what? Will be 60.
60.
So the solution for this inequality, D less than 60. D less than 60. Okay, Mansoor?
Yes, Mister, thank you very much.
Okay, welcome.
Yalla, Mister, see you inshallah tomorrow.
Inshallah. So this is our lesson today. How to find the volume. How to find the volume of rectangular prism. Inshallah, tomorrow we'll continue our lesson today. Today we learned what the meaning of the volume, and what is the formula to solve the volume, and what is the unit to measure the volume. Inshallah, tomorrow we'll continue these ideas. Thank you for your listening. See you tomorrow, inshallah. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh.